Hey everyone, welcome back. Hope you're doing well. In this lesson from Module 5, we're going to look at the earned value method, a way to measure how a project is doing in terms of time and cost. Here's what we're aiming to cover in this lesson. First, you'll get familiar with the key ideas behind the earned value management method, EVM for short. We'll break down what it is, how it works, and why it's such a powerful tool for managing projects. Next, we'll look at how to actually use EVM to figure out how a project is doing in terms of both schedule and cost. You'll learn how to measure whether a project is on track, running late, or going over budget. We'll also use EVM to predict how the rest of the project might go, like how much more it might cost, based on how things have been going so far. And finally, we'll go over how to create and read EVM charts. These visuals make it a lot easier to see what's happening in a project and help communicate that status clearly to others. This video will focus on the first objective, and we'll cover the other three in the next video. All right, let's start with the basics. What exactly is the earned value method, or EVM? You can think of EVM as a way to keep an eye on how your project's doing. It helps answer two really important questions. Are we staying on budget, and are we staying on schedule? To use this method, we need a few key pieces of information. First, we need the baseline schedule. That's the original plan for how the work was supposed to go. Then we need to know how much work has actually been completed so far. We also need to know how much money or effort, like man-hours, has been spent up to this point. And finally, we need to set a status date, which is just the point in time when we're checking in on the project. With all that in place, we can start using EVM to really understand how the project's performing. Let's talk about how we figure out % complete for an activity. In other words, how much of the work has actually been done. There are a few different ways to do this, depending on the type of activity. First is the units completed method. This one works best when each unit of work has the same value. So, for example, if you're building 5 footings and you've finished 4 of them, you're 80% done. It's simple. Just count how many are done out of the total. It's great for repetitive tasks where every unit is the same, like pouring identical footings or assembling furniture. Next is the incremental milestones method. This is helpful when an activity has several steps or phases. You assign a percentage to each step based on its importance or effort. Like if you're doing a concrete work, you might say formwork is worth 40%, rebar is 70%. And once the concrete is poured, that gets you to 100%. This method is best when the activity is more complex and you want to recognize progress step by step. Especially helpful when some steps are more time consuming than others. And then there's the start-finish method. This is usually used for quick tasks. You assign a small percentage, like 30%, just for starting the activity, and then the rest when it's fully finished. So before it starts, it's 0%. Once it begins, you mark 30%, and when it's done, you go all the way to 100%. This method is simple and works best when things happen fast and you just want to capture the fact that work has begun. Each method works better in different situations. Picking the right one helps make your project tracking a lot more accurate. All right, let's break down the key formulas used in earned value management, or EVM, in a way that's easy to digest. So first up, we've got planned value, or PV. This tells us how much work we plan to get done by a certain point in the project, based on the schedule. Planned value is the percentage of work we plan to complete, multiplied by the total budget. You might also hear it called BCWS, budgeted cost of work scheduled. Basically, it's the budgeted value of what should have been done by now. Next, we have earned value, or EV. It's also called BCWP, which stands for budgeted cost of work performed. Earned value tells us how much of the budget corresponds to the work actually finished so far. The formula is simple. Earned value equals the percentage of work actually completed multiplied by the total budget. Then comes actual cost, or AC. This is also known as ACWP, which stands for actual cost of work performed. This one's straightforward. It's the real amount we've spent so far. In other words, it's what we've actually paid for the work that's been done. Now, one thing to keep in mind when we talk about these values, PV, EV, and AC, they can be in terms of man-hours or money, depending on how the project is tracked. So you could be working in dollars, or you might be tracking labor effort in terms of hours or days. These formulas are the foundation of EVM, and we'll be using them a lot to see how a project's doing, whether we're on track, ahead, or falling behind. Let's walk through this example to better understand the concepts of planned value and earned value. A task is assigned to a crew of 5 workers. According to the baseline schedule, the task is planned to start on day 1 and finish on day 5, giving a total of 5 working days. With 5 workers contributing each day, the total planned effort is 25 man-days. Since the task was divided evenly over 5 workdays, every day we need 5 man-days, or 20% of the total work. According to the as-built schedule, the task did not start on time. It was delayed and did not begin until day 3 and finished on day 7. Let's walk through what happens to the project, day by day, then compare the planned value, PV, the budget for planned work to the actual earned value, EV, which is the budget for the completed work. On day 1, the plan says the task should begin, so the planned value is 5 man-days, representing the 20% of the total budget. However, in reality, nothing happened. The task didn't start, so the earned value is 0. No work means no earned value, and we're already behind. Moving to day 2, still no work was made. According to the original schedule, 2 days of progress should have been made by now. That puts the planned value at 10 man-days, or 40% of the budget. We continue to have 0 earned value as the task still did not start. On day 3, the crew finally got to work. By now, the schedule says 3 days of work should be done. That means the planned value rises to 15 man-days, or 60% of the total budget, but with only 1 day of actual work completed, or 20% of the total task. Thus, we only earned 20% of the total budget, giving us the earned value of 5 man-days. We've made a start, but we're still behind the plan. Now, on day 4, work continues. The baseline schedule calls for 4 days of completed work. That sets the planned value at 20 man-days. In terms of actual progress, 2 workdays have been completed, putting the task at 40% complete. So, the earned value is 10 man-days. By day 5, we've reached the final day of the original plan. That brings the planned value to its full total budget, 25 man-days. But the crew has only finished 3 days of work, or 60% of the task. So, the earned value is 15 man-days. The job isn't done yet, and now we're officially behind schedule. Moving into day 6. The plan is finished, so the planned value stays capped at 25 man-days. Today, the team finished another 20% of the work, making a total of 80% complete. So, the earned value is 20 man-days. Finally, on day 7, the crew now completely finished the remaining work, put the percent complete at 100%. The planned value remained at 25 man-days, while earned value increased to 25 man-days, matching the planned value. To sum it up, planned value reflects the work you intended to complete by a given point in time, based on the original schedule. Earned value shows the actual amount of work completed, expressed as a portion of the total budget. By tracking both day by day, you get a clear picture of whether your project is ahead, behind, or right on track, helping you manage time, cost, and performance with confidence. Let's keep going with the EVM formulas. This time, we're talking about schedule variance, or SV. So, schedule variance equals earned value minus planned value. In simple terms, this tells us how much ahead or behind we are in terms of work, not time. Here's how to read it. If SV is 0, it means we're right on schedule. We've done exactly as much work as we planned by this point. If SV is greater than 0, we're ahead of schedule. We've finished more work than we expected to by now. And if SV is less than 0, we're behind schedule. We haven't done as much as we should have. It's a great way to spot delays or early progress before they turn into bigger problems. Just remember, SV tells us about progress measured in value, not in days or weeks, so we're looking at it from a performance and cost planning perspective. Now, let's talk about cost variance, or CV. This one helps us understand how we're doing in terms of spending. The formula is pretty simple. Cost variance equals earned value minus actual cost. In plain language, we're comparing the value of the work we've actually done to what we've actually spent to do it. If CV is 0, we're on budget. We've spent exactly what we expected for the work completed. If CV is greater than 0, we're under budget. We've done more work than we've paid for, which is a good sign. If CV is less than 0, we're over budget. We've spent more than we should have for the amount of work done so far. So CV gives us a quick look at how efficiently we're using our resources, whether it's labor hours or dollars. All right, next up is the Schedule Performance Index, or SPI. This is an alternative measure to assess project schedule. SPI is earned value divided by planned value. If SPI is equal to 1, we're right on schedule. We've done exactly the amount of work we were supposed to by this point. If SPI is greater than 1, we're ahead of schedule. We've done more work than planned so far. If SPI is less than 1, we're behind schedule. We haven't completed as much as we were supposed to. Finally, the Cost Performance Index, or CPI. The formula for CPI is earned value divided by actual cost. We can use this measure instead of cost variance CV to evaluate the project spending status. If CPI is equal to 1, we're right on budget. We're spending exactly as planned. If CPI is greater than 1, we're under budget. We're getting more work done for less money than expected. If CPI is less than 1, we're over budget. We spent more money than planned for the work we've completed. Depending on the CPI and SPI, a project can fall into one of 9 possible scenarios. If the project is on schedule and on budget, both the CPI and SPI will equal 1. This situation is right in the middle, a desired outcome where everything is progressing as planned. Moving to the top right corner of the chart, we find the most favorable condition. The project is ahead of schedule and under budget. In this case, both the CPI and SPI will be greater than 1, signaling optimal performance. On the opposite side, in the bottom left corner, we find the worst case scenario, which should be avoided at all costs. Here, the project is behind schedule and over budget. Both the CPI and SPI are less than 1, indicating the need for immediate corrective action to get the project back on track. Adding color codes to the matrix like this can help you quickly and intuitively assess the health of a project, allowing you to take appropriate actions more effectively. When the project turns red or orange, it signifies issues that require immediate attention and solutions. Now, let's go over a couple more important formulas in EVM that are particularly used for forecasting the project cost at completion. First, we have BAC, which stands for budget at completion. It's simply the total budget you planned for the entire project from the beginning. Next, we have ETC, which stands for estimate to complete. This tells you how much more money you'll need to finish the project. Estimate to complete equals the total budget at completion minus the earned value, all divided by the cost performance index of the remaining work, CPIR. Here, CPIR, the cost performance index of the remaining work, is based on how you expect the future performance to go. You can calculate CPIR in two ways. If you think the project will continue performing at the same efficiency as it has so far, then use the cost performance index of the completed work. If you expect the performance to return to the original planned level, then set CPIR to 1. The ETC formula above is essentially derived from the CPI formula. As you learned earlier, CPI is calculated as earned value, EV, divided by actual cost, AC. Let's assume a certain activity is in progress and some portion of the work has been completed, with remaining work still to be finished. For the remaining work, the CPI for that part, or CPIR, is calculated as the remaining value divided by the estimated cost to complete it, since the remaining work hasn't been completed yet, and we need to estimate its cost. The remaining value is simply the total budget, BAC, of the whole activity, minus the earned value, EV, from the completed work. If we substitute this into the CPI formula, we get a new form of the CPI that applies to the remaining work. To solve for ETC, we rearrange the equation, multiply both sides by ETC, and then divide both sides by CPIR. This gives us the formula for estimating ETC, and that's how we derive the ETC formula. Now, let's look at two more key formulas. EAC stands for estimate at completion. This tells you how much the project is expected to cost in total by the time it's finished. We calculate it by adding the actual cost, AC, to the estimate to complete, ETC. Finally, CVAC stands for cost variance at completion. This shows the difference between the budgeted cost and what you expect the final cost to be. Cost variance at completion equals the total budget at completion, minus the estimate at completion. These formulas help you forecast how the final costs will turn out. Now, let's take a look at the EVM chart, a powerful visual tool for tracking project performance over time. The EVM chart typically shows three key curves: planned value, PV, which represents the budgeted amount of work that should be completed by a certain point in time; earned value, EV, which shows the value of the actual work performed based on the budget; actual cost, AC, reflects the real cost incurred for the work done. By comparing these curves, we can instantly see if a project is ahead of schedule, behind schedule, under budget, or over budget. For example, on this chart, the EV line falls below the PV line from the project beginning to the status date, indicating that the project has been behind schedule during that period. The EV is also below the AC, so costs are running over what was earned. The project is over budget, which is not a good sign. Alright, that's it for this video, where we walked through the key formulas of the EVM method to assess the project status, as well as forecasting the final project cost. Thanks for watching, and we'll see you in the next video. Goodbye!